Just waiting for the thumbs up there. Got it. Well, good evening everyone, and welcome to the planetarium here at Glasgow Science Centre for tonight's David Elder Lecture, which is generously supported by the University of Strathclyde. I'm going to be handing over to our speaker, Professor Lewis Dartnell, in just a moment, but before I do, we need to do the bit that everybody has come here for, which is, of course, the health and safety. Yay! So, as you can see during the lecture, we are going to bring the lights down a bit, so it is going to get harder to see. So from now on, it would be best if you stay in your seats. But if you need anything during the lecture or you want to leave, don't be shy. You always have two helpers in here. My name's Nina, and you also have met my colleague Erin on the way in. Just give us a wee shout, a wee wave, or of course, a wee yoo-hoo. We'll come and get you, and if you want to leave, we'll lead you out one of the doors at the back. During the lecture, we do ask that things like phones, cameras, anything super bright gets tucked away in a bag or in a pocket. And as always, you do get brownie points if you can make sure those are on silent before you pop them away. If anything exciting was to happen tonight, like a fire alarm, all the lights will come on. We will meet you at the back wearing some very stylish high-vis waistcoats, and we'll lead you down some stairs and out into that slightly changeable Glaswegian evening. At the end of the lecture, you'll be delighted to hear that you can get a jump on your Christmas shopping. Lewis will be outside signing some copies of his fantastic book Origins, as well as a couple of others. You will be able to buy those. Unfortunately, it is card only, just to be aware of that. Of course, we are excited about having a bit of a Q&A at the end of the lecture, so if you have a question in the audience, please do just pop your hand up. If you are joining us on YouTube, and I think there's about 50 of you doing that, just pop your question into the YouTube chat and preface it with question in all caps. Makes it much easier for us to find. That's all the boring stuff out of the way. So all I'm going to ask you to do now is join me in welcoming Professor Lewis Dartnell to the stage to talk about origins, how the Earth shaped human history.
Good evening, everybody. Thank you all so very much for coming along tonight. My name's Lewis. I'm a professor at the University of Westminster down in London. And the topic of my research, what my science is all about, is in a relatively new field of science called astrobiology, which is all about looking into the possibility of there being life beyond the Earth. So I've come from a biology background, and then through the course of my PhD and subsequent research, I've been extending what we know about the origin of life on Earth, the conditions we think that life can tolerate. And I spend most of my time thinking about our next door neighbour planet, Mars, and whether it has ever offered a suitable environment for life to have got started. And if so, what would be the best way to hunt for these Martians, for these ultra-hardy bacterial cells on the Martian surface? That's my day job, if you like, helping in the hunt for aliens. But alongside that research, I also spend a lot of my time doing this sort of thing. Speaking to the public, getting involved in media and journalism, and writing books as well. And my previous book was called The Knowledge: How to Rebuild Our World from Scratch. And this is a thought experiment. Let's imagine that there's been some kind of global catastrophe, a doomsday event, an apocalypse, and the world as we know it has collapsed. The vast majority of the human race has been wiped out. Civilization has crumbled, and we are a community of post-apocalyptic survivors trying to work out how to go about rebuilding everything from the ground up. What one book would you want passed into your hands that tells you everything you would need to know about how to navigate back through this network of science and technology that tells you how to make everything from scratch yourself? All the things we just take for granted in our modern lives. Could you reboot civilization itself after an apocalypse in the way you would reboot a computer after it's crashed? So effectively what I was exploring in that book was, could you do this for real? Could you do Minecraft? Could you start on a blank, empty landscape and know where to go to gather the most useful natural materials and resources and extract things like metals out of the rock and do simple chemistry to convert between different useful substances and start pulling yourself back up by your own bootstraps and recover the world, a technological industrial civilization, after a big reset button has been pushed? My most recent book, the one I'm speaking to you about tonight, Origins, is where I've tried to zoom out on that scope even more, not looked at the history of science and technology and the making of the modern world we live in today with the knowledge, But in this more recent book, I've been exploring how features of the planet itself that we live on have had a hugely influential, guiding influence on the whole course of human history, from our origins as a species, through the emergence of civilizations, through the millennia of the rise and fall of different cultures and societies and civilizations, and again, the making of the modern world, and even how you can see the distinctive fingerprint of planetary processes in politics and how people choose to vote. Now, what I'm going to try and do for you in this talk is cherry pick out just a few of the stories, a few of the narratives that I tell in Origins, the ones that I thought were the most mind-blowing and interesting when I was researching and writing this book. And we'll start our story right at the beginning with the origins of us, the making of humanity as a species. Now, we diverged, the human lineage diverged from our common ancestors with chimpanzees maybe 6-7 million years ago. You can see our family tree over on the left here. And over this evolutionary history, these hominin species, these human-like species, have transformed from being hairy, tree-swinging, ape-like creatures into naked, hairless, bipedal, walking upright, very brainy, very intelligent human species. And alongside this biological evolution on the left, we've also undergone a huge amount of technological evolution on the right, through the Stone Age, revolutions in Stone Age technology. Now, all of this story, all this biological evolution, the making of us as a species, this all played out in this part of the world. This is East Africa, and specifically in the great East African Rift Valley. That was the cradle for us as a species. And incidentally, it was also where I spent my own childhood. I grew up in Nairobi in Kenya. I went to a school called the Banda, which is Swahili for mud hut. I went to the mud hut school in Nairobi, and I've got many, many fond memories from my childhood with my family driving out on safari across this ancestral landscape, across the savanna, the grasslands of East Africa, where we developed as a species. Now, fundamentally, what needed to happen to drive the evolution from hairy, tree-swinging, ape-like creatures to bipedal, upright, human-like species was you have to transform forest into grassland. You have to dry out East Africa beneath our feet while we were living there. Now, if we zoom out from this view, you're going to see a whole lot of maps in this talk, by the way. I mentioned that I've come from a biology background, and when I was researching and writing Origins, I became all about the maps. I became a massive geography nerd. And everything you're about to see, all of these graphics are cartography, maps that I've created myself using some software that I wrote, so I could overlay different maps, different patterns on top of each other, and show you these profound links between the physical world, the planetary environment, the Earth, and aspects of human history. Now, if you look at this map of the whole world, of the globe, and allow your eye to just scan across the equator, across the midriff of our planet, you'll notice that this is where we find all the great rainforests of the Earth, the Amazon, the rainforests of Central Africa, the rainforests smothering the archipelago of islands in Southeast Asia. The equator is where you find rainforest. And that is true the entire way around the planet, all apart for this weird little corner of East Africa where we were growing up, where we were evolving. East Africa is dry when it should be wet and covered in forest. And what explains this change is a tectonic process. Over the last 5-6 million years, as we've been evolving in East Africa, a huge plume of mantle has been rising up from deep in the interior of the planet and pushing up into the underside of Africa, of the continental plate of Africa, and it's swollen up like a huge zit on the face of the Earth. And as that crust has thinned out, it's cracked and split in a characteristic Y-shaped pattern of fractures. It opened up the Red Sea, it opened up the Gulf of Aden, and the third arm of this characteristic Y-shape tectonic fracture runs a long way south through the continent of Africa, which is this great Rift Valley. And alongside, each side of this Rift Valley, it's very mountainous and high. There are walls that are effectively blocking the moist air from the ocean, blowing across into East Africa, or moist air from the interior rainforest, blowing the other direction across East Africa. It was this planetary process which dried out East Africa while we were living there. But plenty of places around the world have dried out, and you evolved the camel. So what was unique, what was special about this part of the world while we were living there? Well, it turns out that the pattern, the story, the answer that's been emerging in just the last few years is that there's a very particular combination of planetary processes that all came together here. There's the formation of this tectonic crack, the Great East African Rift Valley, and that landscape interacts with cosmic cycles, known as the Milankovitch cycle, so wobbles in Earth's tilt, the axial tilt of our planet, wobbles in our orbit around the sun. And that interaction has created periods of climactic chaos, climactic instability, where for periods of time, a whole string of lakes, which I've shown in blue, that run along the bottom of the Rift Valley floor, would flicker in and out of existence, cycling between periods of wet, dry, wet, dry, wet, dry. And every time these lakes flicker in and out of existence, like a loose light bulb that's flickering in your basement, it changed the entire environment for our ancestors. It changed the amount of water, it changed the amount of vegetation that's growing, it changed the amount of game, animals that we could hunt. So we developed big brains. We evolved our intelligence so that we could outthink an unpredictable environment. It was a planetary process. It was a plate tectonics which gifted us with our high intelligence that enabled us to come to dominate the world and develop civilizations. Now, it wasn't just these climactic processes which drove our evolution. Another period in Earth's climactic history enabled us to come to disperse and migrate around the entire world. We didn't remain in our cradle in East Africa. We've come to disperse and migrate around the entire planet. We are the most widely dispersed animal species on the planet today. And that opportunity was offered to us by the last great ice age, a period when, again, because of these Milankovitch cycles, wobbles in Earth's orbit and tilt, cooled down the planet. Huge great ice sheets formed over a lot of the northern hemisphere in the high latitudes. Sheets of ice which are up to 4 kilometers thick in places. And this drew so much water out of the oceans that the sea levels around the entire planet dropped by over 100 meters. So large areas of what would have been seafloor became dry land. And we were able to simply walk between the continents. We migrated out of East Africa, through the Arabian Peninsula, across the southern margin of Eurasia, and then without getting our feet wet, we could walk through what would have been the archipelago of Southeast Asia towards Australia. But then much more significantly, we're able to walk across the Bering land bridge, which appeared to link the continents of Asia and North America. Now, there had been previous human-like species, hominin species, which had migrated out of Africa. Neanderthals covered Europe when we arrived there. The Denisovans had got to Central Asia. Homo erectus had got as far as Japan and China. But we are the only human species to have ever made it across into the Americas. We trod where no human species had ever trod before. And then with the thawing out of the planet, the easing of the last ice age, the sea levels rose, and once again that Bering land bridge was swallowed beneath the waves, and the two great hemispheres of the Earth, Eurasia and the Americas, once again became severed and separated. And humans around the planet began to independently work out how they could domesticate wild plant and animal species, to develop crops and livestock, to invent agriculture and develop civilization. The whole history of human civilization exists in this short blip since the most recent ice age, after we dispersed out of Africa. Now, one of the regions on the Earth, which has been an absolute bubbling cauldron, a hot pot of different cultures and societies and civilizations and empires, has been the Mediterranean. And you'll be familiar with a whole suite of different peoples and societies, from the ancient Minoans through the Mycenaeans, the ancient Greeks, the ancient Romans. But when you think about it, all of these Mediterranean societies and cultures, on the whole, all existed along the northern rim of the Mediterranean Ocean. The Mediterranean is not big at all. It's a tiny little sea completely surrounded by land. You can cross the Mediterranean without ever losing sight of land for most of it. So why is it that for thousands upon thousands of years, there's been this huge disparity in human activity between these two different lips, the northern and southern coastline of this oval, mouth-shaped sea? And to understand that profound pattern in human civilization, we have to understand where the Mediterranean came from in the first place. And it turns out that the Med today is no more than a mere puddle left behind from what was once a vast, great ocean called the Tethys. So if you wind back the clock of Earth's history, you can see on the top left here that this is a map of what the world looked like 240 million years ago. So almost 250 million years, and our planet's past. And back then, the constant scuttling of the continents across the Earth's face with continental drift had brought all the great land masses together, colliding and fusing into a single giant landmass, a supercontinent called Pangaea, the all-land. And held within the cup of this C-shaped supercontinent, there was a great ocean called the Tethys. No sooner after Pangaea had formed, the process of plate tectonics began to once again tear it and rip it apart to create the fragments of land we're familiar with of the continents of today. North and South America tore off. Africa and then India began riding back north again to slam and collide into the underside and the belly of Eurasia. And during that process, as Africa and India rode north, the Tethys Ocean became destroyed. It was swallowed up. It was subducted into the interior of the Earth and destroyed. And so all that remains today of this once great ocean is this puddle of the Mediterranean Sea. And it's that fact that explains human activity over thousands and thousands of years. It is Africa that is riding north into Europe, and it is Africa that is diving beneath the continental plate of Europe. It's Africa that's being subducted in those plate tectonics. And as Africa has collided into Europe, it's crumpled up long chains of linked mountain ranges, including the Alps. And with the rising sea levels after the end of the last ice age, this crumpled up, rumpled landscape of the North Mediterranean coastline became an inundated landscape full of lots of archipelagos, of little islands, of natural inlets and coves and natural harbours. The northern coastline of the Mediterranean is ideally set up for seafaring, for communicating and trade across by ships. Whereas if you look, the southern coastline of the Mediterranean, the African coastline, by comparison is very boring and straight and flat. About the only natural harbour that exists for thousands of miles across the African coastline is where Carthage appeared. Can you see my mouse? There. That's where Carthage appeared and came to challenge the might of even the Romans before they were utterly obliterated, literally wiped off the face of the map at the end of the Punic Wars. But for thousands of years, there was this huge disparity in human activity and the appearance of civilizations, all coming fundamentally down to plate tectonics and continental drift. Now I want to move on to a couple of chapters later in the human story, and incidentally, a couple of chapters later in the book, in Origins, and look not at the movement of the ground beneath our feet, at plate tectonics and continental drift, but at the churning of the atmosphere high above our heads, at global atmospheric circulation, and how that creates the patterns of winds around the world. And we'll start our story in this part of the world here. Now, this map might be slightly confusing because I'm showing you here not the landscapes on the continents, not the landforms, but I'm showing you the landscapes on the bottom of the ocean. In shades of blue on the left here, we're seeing the seafloor of the North Atlantic. And you can clearly see, running right along the left there, this huge scar along the face of the Earth, which is the Mid-Atlantic ridge. That is where the plates are still being forced apart and the Atlantic Ocean is still growing wider and wider. You've got the bulge of Northwest Africa up here, and then north of that is Europe with the Iberian Peninsula sticking out into the Atlantic. Now, where we pick up our story, in the early 1400s, Europe back then was an uncivilized place. We were uncultured, uneducated, unadvanced. We were backwards, certainly in comparison to the other civilizations of Eurasia, such as China and India. We were right on the western extremity of this broad, sprawling continent of Eurasia. We were right on the end of all the trade networks, such as the Silk Roads, that moved not just silk and porcelain and spices and trade goods across the continent, but also human ideas and thoughts and philosophies and discoveries and technologies. We didn't receive the blast furnace for making steel in Europe until 1,000 years after it had been developed in China. And in the early 1400s, when Europe started looking outwards, wanting to explore into the wider world, we couldn't simply head east, following back along the track of the Silk Roads, because by this point, a powerful Islamic empire had emerged and closed the door for us to the east. So instead, we had to look in the opposite direction, out to the west, out into the stormy, vast gulf of the North Atlantic. And the stepping stones that first started drawing out Portuguese and Spanish navigators, sailors into the Atlantic Ocean, were islands like Madeira, the Canary Islands, the Azores. You can see in the map here that these islands are no more than the very, very peaks of huge underwater mountain chains. The Azores, in fact, are the tips of giant volcanoes making up part of that Mid-Atlantic ridge. And the Portuguese started heading down the northwest African coastline, following the way that the direction of the winds or the ocean currents were already taking them. But then to get back home again, they faced a fundamental problem of sailing ships. To get back home, you can't simply turn around and go back the way you came, because you'd fight against the very winds and ocean currents that took you there in the first place. And so the Portuguese realized that the key, the secret to effective sailing through oceans was something completely paradoxical at this time. In order to get home, you have to turn away from the land, sail away from the coastline, away from your sources of food and water and the landmarks that you know how to navigate by, and just head blindly out into the empty expanse of the ocean, until you pick up a different set of winds, a different set of ocean currents that can take you back home again. The Portuguese completed what they called a volta do mar, a return of the sea. And when they headed further down northwest African coastline, this great big loop they had to steer through the Atlantic to bring them back home again took them across the Azores. No human had ever stepped foot on the Azores before. They were utterly uninhabited when the Portuguese sailed there. And so what these early mariners were doing was starting to piece together the patterns in where the prevailing winds blowing in different directions can be found, where the ocean currents are flowing in different directions. This was just one part of the jigsaw puzzle. And we've now come to piece together that global picture of how the atmosphere moves and where the winds can be found. And it makes some simple sense. Around the equator, where it's very warm, the air warms up and it rises and cools down, and any moisture that's evaporated condenses and falls back down as rain. That's why we find all of the rainforests around the equator, as we saw earlier. And that rising air then rolls over through high altitude, and then now it's cold and dense, and it sinks back down to the Earth's surface at about 30 degrees north and 30 degrees south. That cold, dry, descending air creates the bands of the deserts that we find around the planet. The rainforests and deserts are just expressions of the atmospheric circulation. And then to complete that great big vertical circulation current, the atmosphere has to return to the equator along the surface. And the atmosphere moving across the surface is just what we call the winds. The only other important feature in this story is that as the atmosphere is doing these huge vertical currents, the entire planet is rotating beneath its own atmosphere. This creates what's known as the Coriolis effect. It deflects the winds to the same direction. So either side of the equator, we have a wide band of winds which always blow towards the west. Those are the trade winds. And then beyond that band, when the atmosphere is circulating in the opposite direction, you get a band of winds blowing the other way, the westerlies. It was realized that if you want to span an entire ocean and trade between continents, the solution becomes an issue of just moving your ship north and south between these opposing bands of winds. They're like conveyor belts wrapped around the entire planet that will take you one way across the entire ocean and then back again to where you came from. And so European navigators... I threw in a slide just to show that we see exactly that. I'm in a planetarium. I want to show a picture of a planet as well. We see exactly that same process in other planets, particularly gas giants such as Jupiter, where these zones and belts are effectively the Jovian expression of that same atmospheric circulation system we see in the Earth, with winds moving in different directions, with areas of upwelling and downwelling. And these European navigators worked out how to exploit these prevailing patterns of winds and ocean currents to knit together the continents in a way that had never before been seen in human history. The Portuguese eventually found their way all the way down to the bottom tip of Africa before they could turn left, start bearing east across the Indian Ocean to the Spice Islands. They were seeking the source of the spice they could come to dominate that trade. It turns out that the only way you can sail south around the bottom tip of Africa, going the way that the winds are blowing, is by steering such a large loop through the South Atlantic that you stumble across the coastline of South America. The reason that Brazil speaks Portuguese, whereas the whole rest of South America speaks Spanish, is simply that is the way the wind was blowing when the Portuguese were trying to head in the opposite direction towards India. The Spanish found their way across the Atlantic, with Columbus, of course, and then explored land across this continent, across the thin sinew of land linking North and South Americas of the Panama, Isthmus of Panama, and then they became the first European eyes to ever see the ocean on the far side of this new world. They called it the Peaceful Ocean, or the Pacific. And then the Spanish established the longest range trade route in the entire age of sail, the Manila galleon route, bridging right across the Pacific. They started off in China, loading up with lots of silk and trade goods, sailed north up to Japan, where they knew they could pick up that band of westerly winds, allow that to blow them across the entire stretch of the Pacific, the greatest ocean on the planet, until they reached the coastline of North America. Then they headed down the shore until they reached Mexico, where they had lots of their silver mines, filled up the hold of their ships with silver, and then allowed the trade winds to blow them all the way back across the Pacific to China. The reason that California was so geopolitically significant for hundreds upon hundreds of years, the reason that cities like San Jose and San Francisco and Los Angeles were founded in the first place, is simply that is the only place you can get to after sailing across the Pacific. That's where you need to establish your ports to resupply your ships. That's where the cities start growing up. The Dutch found a shortcut across the Indian Ocean, cutting out the Portuguese from that valuable spice route. And they did this by exploiting a particular band of winds in the southern oceans known as the Roaring Forties. These are particularly powerful, fast-paced set of winds. It's effectively a motorway, an invisible motorway in the ocean. And it was Dutch captains sailing on this Brouwer route they established that discovered Australia from a European point of view. This is why South Africa speaks Afrikaans, a Dutch-based language. because the Dutch had to establish a port before that long crossing of the Indian Ocean. Now, the problem with using this motorway across the ocean of the Roaring Forties is you've got to know when to take your turn off from that motorway. If you hang a left a bit too late, you slam into the continent of Australia. You would not believe the number of shipwrecks across the western coastline of Australia where captains had missed their turn off. They'd missed an entire continent and ploughed into it because of the difficulties of navigation. Now, finally, but arguably of the greatest significance for the subsequent playing out of human history, was the Atlantic trade triangle. And this was established in the early days of the Industrial Revolution, when Britain and then the rest of Northern Europe worked out how to get machinery to make stuff for us. We could start mass producing textiles, clothing, and weapons, which we then sailed down the old Portuguese route to the coastline of northwest Africa, sold all of that, manufactured goods, and then bought human labor, slaves. People were thrown into irons, loaded into the holds of these ships, sailed across the trade winds route to the colonies in North and South America, and then forced to work on the plantations, growing raw plant products like tea, coffee, sugar, cotton. And then the products, the product of that slave labor was then sailed back across the westerly band of winds to Britain, where we took that raw cotton, turned it into textiles and clothing with our machinery, sailed it back down the old Portuguese route to northwest Africa, and so on and so on. This Atlantic trade triangle was like a giant economic cog sat right across the ocean, being blown round and round in circles by atmospheric circulation, by the prevailing winds, and generating enormous profits with every turn of that cog for its masters, for the slave masters. And so all of this story, all of this narrative, this history of European exploration and colonization and exploitation and empire building, where ports were founded, where cities grew that we live in today, all of that was determined by atmospheric circulation. That dictated where we had to establish our trade routes. That determined where we had to establish the ports and the cities and the fortresses. We still see the fingerprint of wind patterns in the way the world is set up today. And it's not just through historical process like this that we see that distinctive fingerprint of the planetary processes. We see it even today in politics and how people choose to vote. An example I've got of that for you is this part of the world here, which is the southern states of the US. And if I peel off this satellite view and show you the political view, unsurprisingly, the southern states in the US are, on the whole, a Republican region. But there are Democrat voting counties in the southern states as well. And you'll notice, just by looking at this political map, there's something curious about what's going on with the politics here. There's a structure, there's a pattern to where people are choosing to vote Democrat rather than Republican. The big band on the left, running north-south, that corresponds to the Mississippi River. But what we can also see is this distinctive crescent arcing its way right across the southern states that doesn't seem to correspond to anything we can see on the ground. Looking at the terrain map, this is the Mississippi River on the left. We've got the Appalachian Mountains, which doesn't correlate with that political feature we can see in the map. So if we peel off that terrain map and instead now look underground, look at a geological map, the age of rocks beneath our feet. And what I'm showing you here is rocks on the ground which are about 75 million years old. And if I now overlay again that political map, you can see there's this astonishing correlation. People are voting Democrat if they live on that band of rocks which is 75 million years old. Now this makes no sense at all. Of course it doesn't. These people aren't geologists. They're not going into their back gardens or indeed their backyards, drilling a borehole and going, wanted to vote for the Democrats. I wanted to vote for Biden, but now I have to vote for Trump. I have to be a Republican because the rocks are telling me. There's no direct link from the geology to how people are choosing to vote. But what there is a long chain of cause and effect, of one thing leading to the next, stretching back through hundreds of years of human history and then millions of years of our planet's history. And the chapter in Earth's history 75 million years ago was called the Cretaceous. And back then, the sea levels around the Earth were much, much higher than they are today. The ocean lapped right up through the middle of North America in this great inland sea. And so the rocks laid down then were effectively thick sediments of seafloor mud, became buried and compacted, and then exposed again by erosion along this particular crescent. The rocks to the north are slightly older, the rocks to the south are slightly younger. And it was realized in the mid-1800s that when that Cretaceous rock, that rock that's come from seafloor mud originally, gives you a soil, it gives you a soil which is particularly thick and black and fertile. A soil which is perfect for growing cash crops like cotton, which you could sell back to Britain. And as we saw already, unfortunately in this period of history, growing cotton meant slave labor. People were abducted from Africa, sailed across the trade winds route, and forced to work on cotton plantations specifically along that band of Cretaceous age rocks. And even today, hundreds of years later, after the Civil War, after the emancipation of slavery, after the Civil Rights Movement, still today the greatest concentration of black African-American people live along that band of 75 million-year-old rocks. People, unfortunately, still suffer from poor socioeconomic opportunities. People are much more likely to vote for Democrat election promises rather than Republican ideals. And the city that I've indicated for you there, Montgomery, is the place where in 1955, a black woman called Rosa Parks refused to give up her seat to a white gentleman on the bus. The very epicenter of the entire civil rights movement, which transformed society in America, began smack right bang in the middle of that band of 75 million-year-old rocks. There's this long chain of cause and effect from economics, through agriculture, through soil type, through the geology and Earth's history that explains this political pattern today. And just to demonstrate, I've not picked the only example around the world where this correlation between the planetary and the political can be seen. I've shown you an example from much closer to home here, from our own British Isles, where on the left we have, in red, constituencies which tend to vote for Labour, the Labour heartlands. And on the right, we have rocks beneath our feet, which are about 320 million years old. And again, you can see this astonishing correlation between people's political preferences and the planetary, geological formations beneath our feet. Now, this particular pattern will become much more obvious to you when I tell you that the chapter in Earth's history 320 million years ago was called the Carboniferous. These are the great coal fields of Britain. This is where we realized we could dig underground to find fossilized forests, fuel that we could dig up, throw into our furnaces, and power our way through the Industrial Revolution. And the last step in that particular chain of cause and effect is that the Labour political party grew out of trade unions and in particular coal mining unions. Now, I've only had time tonight to tell you about just a couple of stories from the book. I've told you I've cherry-picked what I thought to be the most astonishing, the most mind-blowing examples I came across when I was researching and writing this book. But there's plenty more in Origins. These are some of the clickbait examples, other examples from the book, such as what was the original Brexit 500,000 years ago? And what created Britain as an island, as an isolated nation? Why do most of us eat a bowl of cereal or slice of toast for breakfast? How has the planet determined even what we eat for breakfast? Why did the modern financial system arise in Holland? Why was it the Netherlands invented capitalism rather than elsewhere around the world? Why is it that the Great Wall of China is primarily a defensive barrier to keep the barbarians out, but actually follows a fundamental ecological boundary on the planet. It follows very, very closely along a climactic boundary. And if you want answers to any of these, I have shamelessly brought along a couple of copies of the book of Origins. And in fact, I'm not shameless about this. I'm a writer. I pay my mortgage by flogging books. I've flown up from London to speak to you guys. I brought a couple of books with me. You can pick up copies of Origins outside. I can sign it for you if you want. I don't have to. It'll be your book by that point. You can pick up some Christmas presents. I mentioned as well about my previous book, The Knowledge, about how you could survive a post-apocalyptic wasteland and rebuild civilization from scratch if only you had the most useful science and technology written down, how you could do Minecraft for real. And then there's a few copies of my first book, Life in the Universe, A Beginner's Guide, which is about this very new field of science of astrobiology and how we're hunting for life on other planets, life on Mars or Europa, or perhaps on more Earth-like planets orbiting other suns in our galaxy. Thank you ever so much, again, for coming along tonight. Completely for free, completely for nothing, you can ask any questions you have of me. If we bring back up the house lights, please. We do have some time for questions now. If there's anything you'd like to ask about any of the stuff about planet Earth and human history I've been talking about, or rebuilding civilization after an apocalypse, or how we hunt for aliens on other planets. Anything is fair game tonight, anything that has struck your fancy. All right then. Oh, maybe you should applause. People tend to ask questions after applause. Thank you very much for coming. Cheers. You're very kind, thank you. Did anyone have anything they wanted to ask? Is anyone still awake after a lovely, warm, dark hour spent in the planetarium? Yeah. Say that again for me?
How did you come to figure out the realisation of the rocks?
So the question then was, how did I come to figure out that pattern between the rocks and the politics? I did not realise this pattern myself. I did a lot of research when I was writing the book. There we go, there's the cursor, there's the mouse. I did a lot of research when I was writing this book, and I came across an American geologist called Steve Dutch, who spotted this feature of the political map, that Democrat arc, and thought, no, hang on, that looks suspicious like something I see in my geological maps. And he checked it, went, no, absolutely, there is this very strong connection or correlation between the political map and the Cretaceous age rocks. And then he wrote this beautiful paper. You can get it up on the internet. If you go to the book's website, you can click through the link that I provide and you can read it yourself. But he provides this whole chain of maps of the geology, the soil type, the agricultural type patterns seen through history, slave ownership, remaining African Americans, and you can see this constant link from one to the other. I've only showed you basically the beginning and end of that story. He was much, much more thorough and showed you every step of that argument with these undeniable correlations between the two. Yes, sir. Yeah, so I've showed two examples here. I've shown an American example and a UK example. I was on tour a few years ago, book tour, and I went to Australia, and in Melbourne, a geologist came down and said, fascinating examples, Lewis, but do you know about the pattern that we see in Melbourne? And basically what we're seeing is, it shouldn't be a surprise, or it perhaps should be expected that geology in terms of where the rocks are that might have something which is valuable underground that you can mine and dig up, or indeed different kinds of landscape, whether it's smooth and flat or mountainous or hilly, that of course can have a determining factor on where people choose to settle or what sort of industry or residential areas develop. An example in Melbourne was between much more ancient and therefore smooth and flat bedrock, which is where all the heavy industry, the factories, had to be built, and then more recent terrain, which is much more sort of gently undulating and lovely sort of the hills where all the rich people could afford to build the houses. So when you look at the political map of Melbourne, there's this clear distinction between working class tending to be Labour voting or left-wing voting regions, areas of the city, and then tending to be more conservative right-wing voting parts of the city, which is where the posh people live. Those are the examples I mostly talk about, but there are plenty of examples of terrain or rock type having these sort of knock-on effects for where different forms of sort of human land use arise, and therefore political patterns that come out of that. Yeah.
When you were talking about the Rift Valley and the very specific things that had to happen for human evolution, the fact that there were so many sort of nuances and tweaks, does that make you think it's less likely that similar life to humans have evolved on other planets, or does that relate to your search for alien life?
Yeah, so it has been a problem to explain for a long time about why did humans become so intelligent? Because having a big brain is a huge burden on us as an animal. It's an incredibly energy demanding organ. I don't know the exact stat, but it's something like 25 or maybe 30% of all the energy our body uses goes just into our brain. So we have to be very good at finding food to power this organ. So if you've got such an energy demanding organ, there has to be a very good reason why it's necessary. Otherwise you would just have a smaller brain and be less intelligent. And various theories have been proposed over time over what can account for human intelligence, and clearly it comes down to a lot of communication and sort of social interaction between other humans, and that explains later stages, and tool use explain later stages of intelligence. But what was it 5 or 6 million years ago when we were basically hairy apes that began that process of us becoming more and more intelligent? And this seems to be the most convincing planetary or geological explanation of what began that process of greater and greater brain sizes and intelligence. But you're right that there's a sort of confluence of several factors coming together here which created perhaps quite quirky environmental conditions to which the answer was a big brain or intelligence. And when we are talking about astrobiology and the possibility of life on other planets, we tend to mostly talk about boring life, microscopic life, hardy bacteria in the desert surface of Mars, or microbial marine life in the buried ocean, in the subsurface ocean of Europa. But possibly, somewhere out there in the galaxy, there is a planet which is sufficiently Earth-like, that has had a very stable environment for billions of years, where evolution has had the opportunity to get beyond single-celled life. It took 3.5 billion years on Earth for that evolutionary process to happen. Maybe there's another planet out there where there has been a similarly stable environment for long enough that life can progress beyond single-celled life to multicellular life, to animal life, to intelligent animal life, to maybe intelligent aliens building spaceships and radio dishes that we could communicate with each other across the galaxy. Now, we've not seen any evidence of any intelligent life in our galaxy. There's no reason to believe it's out there. We've been listening for 50 years, 60 years with radio telescopes, and nothing seems to be trying to hail us or attract our attention. Which doesn't mean that tomorrow morning we won't receive an interstellar tweet or Instagram post from someone on the other side of the galaxy. So there's always this distinction between astrobiology, which tends to be focused on microbial life in places like Mars or Europa in our solar system, where we can explore with our probes and do tests and do science, versus SETI, or the search for extraterrestrial intelligence, which tends to be a bit more passive. It's more about listening for signals being beamed to us. But from what we know of evolution on Earth, the vast majority of planets which might have life in the galaxy will almost all have bacterial life, primitive life, and very, very few of them, if any, would have complex life. Because the range of conditions that intelligent life can survive under, because the amount of time it takes to evolve, just from looking at the history of life on our own planet. So I tell people that I'm an alien hunter, but then immediately have to clarify, boring bacteria, not little green men. I have never been probed inappropriately when the bright lights appeared in the night sky. I don't own an anorak and stand out on dark fields waiting for the UFOs to come. That was a weird note. Thank you for saving me. Yeah, so the last generations of NASA rovers have detected Martian organics. So carbon-containing molecules, which we've been able to demonstrate are not contaminants from the probe or from Earth. They are definitely from Mars. And that's just another piece of the jigsaw puzzle that Mars seems to have had a habitable environment in the past. It seems to want to be much warmer and wetter with liquid water and a lovely thick atmosphere to insulate and blanket the planet. We now know that there is organic chemistry there, the building blocks of life as we know it. One very exciting mission that ESA, the European Space Agency, has been working on for the last, sort of 10, 12, 15 years now, is called ExoMars, which is a Mars rover mission specifically to look for signs of life. A lot of my colleagues around Europe have been involved in this mission. We were due to launch ExoMars to the Red Planet this summer. Unfortunately, we'd been in collaboration with Russia for launching us and also landing on the planet. And for obvious reasons, with the invasion of Ukraine, it became a little bit politically orcs, a little bit awkward to continue with that setup, so that was abandoned. And we are now hoping, and in fact it seems to be going ahead, that the Americans will be able to launch this European rover to Mars. What is exciting about ExoMars is that with that mission, for the first time ever, we are going to be sending a drill which is 2 meters long to the Martian surface. Because up until this point with the NASA rovers, they've had drills which are basically the length of your little finger. It's kind of been poking its pinky into the side of rocks and extracting out some of that material to analyse. But with ExoMars and its 2 meter long drill, we're going to be able to get handfuls of Martian dirt from a significant depth where it's been hopefully protected and preserved underground from the Martian conditions on the Martian surface. Bring those handfuls of Martian dirt back to the surface, take them into the main body of the probe where we've got basically our miniaturized laboratory, and then analyze and scrutinize that Martian soil, see what complexity of organic molecules might be there, the building blocks of life, but hopefully also detect unambiguous biosignatures, signs of life itself. Possibly extant, possibly life which is dormant and survived until today, probably more likely something which fell extinct a long time ago, possibly even billions and billions of years ago. But by looking at some of the oldest rocks on Earth, we can still detect traces of bacteria that were alive back then. So we've got confidence we're able to do the same on Mars. We tend to land our Martian rovers in places where we see lots of evidence of past water, so like river deltas, where there's been some mud that's collected and might have concentrated in the organics or signs of life. So that will hopefully be launching in the next few years. ExoMars will launch in the next few years. Were there any other questions? We were quite keen to get off to our dinner. In which case, thank you ever so much once again for coming along. Thank you very much to our YouTube watchers. Do you have any final closing up things to say, Nina?
No, just to say a wee reminder, if you would like to purchase the fantastic Origins, we'll meet you outside and I'll try and work out how to use Lewis's fancy card machine. We'll see how that goes, but thank you all so much for coming, and I'd like to all ask you to join me in thanking Lewis for joining us this evening. That was fantastic. Thank you so much.
Thank you very much. The one final thing I'll say is if you want to come up and just chat with me and you didn't want to put your hand up in front of everyone else, I'll be outside as well. Just come up and say hi and ask me whatever you like. Don't feel you had to sort of ask a question in a formal Q&A just now. Otherwise, safe journeys and have a good night. Thank you.